All right. Well, thanks everybody for coming again today. This is our last day and it's sort of wrap up some things. The program today is a little bit of demos from us. It's also some time here for demos from you if you have Strabo data you want to show. And then we're going to have in the afternoon a little bit more about setting up a remote server and what the data structure looks like. So kind of some deep background, but hopefully you'll find that interesting as well. And I think Alex, you're gonna run this morning session, right?
I certainly can, unless you'd like to.
Either way, does anybody have anything from Strabo they want to show? Like Rip.
Yeah, I could show some stuff for, I set up a couple of students last fall to work in Gypsum Valley. I mean in Sinbad Valley. You want me to share?
Yeah, that'd be great.
All right. This was two grad students who we set up to work in Sinbad, and they were sort of Luddites, so they didn't end up using Strabo like I'd hoped they would. But here is the data I started them off with. And it includes both, and the data we collected in about 4 days in the field. So it's about 130 points. And so here was an area that was kind of fun. It's an old mine that has that we actually set up, if I can find it. One of these I set up as a base map. Maybe I can find that. Maybe you guys can help me, guide me as to how to find that. Let's see. By the way, I put things like land ownership, so we know we're on Forest Service land. And you can see we're way zoomed in here. But then the geology that I got from whoa, file does not exist.
Oh no.
I think I deleted it. Oh well. And let's see, old geology, yeah. So I'm sorry I did that. I actually had, I must have deleted that. I had I moved it because the student asked me to move it for him so he could use it in the long run. So that was actually the other day. Anyway, so let me see where we had that. So if we go to satellite, you can see what the geology looks like. This is a salt megaflap. It's a big set of rocks that was sitting on top of the original bedded salt and has been tipped vertical. And it forms this panel through here. And let's see, where is my, let's see if I can find the base. How did I do that base map? You guys know how to sort through these to find a base map?
Was it an image base map?
Because I set one of my spots as a image base map.
Oh, if you go up to attributes.
Yep. There it is.
Oh, well, sorry. Maps, sorry, go to maps.
Yeah.
And then
there are image base maps. There we go. All right. There we go.
Ah, excellent.
So here's one we set up as an image base map. It has strikes and dips superimposed on it. It was a fairly complicated area with two faults running through it. And anyway, so we were able to collect that, and then let's see what else my other base map is here. Oh, and this was one I set up as a, let's see if I can get that. I'm having trouble because I covered the Zoom covers up my,
Oh, yeah.
there it is. And actually, and that covers it up too. Okay, there we go. Now I ought to be able to. And let's see, Silver TRW. Wingate. Oh yeah, that's not it. Anyway, so on here, on this base map are a bunch of strikes and dips that we collected. So if we go to orientations on there, they should be there. Okay. Anyway, I apologize for that one being sort of out of it. Here's a more recent one. This is in El Paso, one of our local, and cut me off if I'm dithering. I don't want to.
It's all good.
Anyway, this was our last 2 field camp projects from this year. And it is in the northern part of the Franklin Mountains. And so here was the area for our second project. We usually pick places that got mismapped for one reason. These, you can see there's a whole bunch of spots we collected. About a quarter of these we made available to the students. And so that they would have them so they could work virtually in QGIS. And anyway, you can see the sort of density of data we got, and lots of images. So that was a shear band in along a fault. And anyway, is there anything anyone would like to see on that? And it looks like my computer has now frozen.
Okay. Well, that was great, showing some different examples of things. Does anybody else in the audience have any Strabo stuff they would like to show? Raise your hand or turn on your camera, whatever. And if not, I've got a project I can show to you guys.
And I also have a project that I can show if you want, Doug.
I'll do this one real quick, and then if you want to get the other one ready, that'd be great.
Sure.
This will be simple. So, all right. So one of the ways that I've started using Strabo with people that I'm doing work with is that you can kind of take them on field trips as you're doing field work. And so I've got a research associate here, and he and I are working on some faults in California together. He's out in the field right now. And when he's out in the field, he can upload his data and his images, and I can look at them. And if I'm out in the field, he can do the same. So I'll just show an example here. There we go. So this is, I'll zoom out here. This is out in the California desert area. It's the area around the 2019 Ridgecrest earthquake, which was up here in China Lake and near Ridgecrest, California. But right after the earthquake, we went out, or a group of us went out and started looking for faults and offset markers. So for example, in the that year, and I'll put a satellite image up here. Oops. Oops. There we go. So you can see this band of rocks right here correlates with the band of rocks right here. This is essentially, these rocks are less than 3 million years old. They're not really rocks. But this darkish looking contact here is the same darkish looking contact there. Anyway, we were able to go out, do this work, look at an offset marker here, and then we're able to, while we're doing this, share images with each other of anything we picked up. So for example, this location, a little anticline in the most recent exposure surface. And then when you get down to this area, looking at, for example, some of the layering in the dirt or pretty well cemented dirt in this area. So right now, Joe Andrews out in the field, and we're trying to put together, let me back out here a little bit. This is areas of Mesozoic basement rocks. We're trying to put together offsets across it. So I've been going in, Joe's been mapping, and then he can call me in the evenings. And then I can look at some of the structure that he's found to work on. So really scaly gouge zone along a low angle fault and other features like that. So one of the things that I found with Strabo Spot that can be really interesting is just this idea of working with other people in semi-real time. I hope everybody was seeing the map I was displaying. Okay, good.
Yep.
So just kind of to go back out onto the search part of this. This is data, and like I said before, Joe Andrew has JEA maps, has a lot of data in here. And for example, there's a place called the Lava Mountains. This is something that came in with GIS. So this was brought in as a shape file, and I'll just zoom in here. Again, a shape file coming in, and you can get at orientations, read anything in there that you want, etc. So this was mapping that was done 10 years ago. Again, all mapping that was done in ArcMap. And then now converted straight to Strabo. These data can be downloaded, viewed, do whatever you want with them as well. And it's all in here. So if you wanted to come in and grab this data and look at it, for example, as a Stereonet example, which we'll be seeing a little later, you could bring that in and look at data that way. So just kind of a couple of examples in Strabo Spot of data that have come in. So I'll stop sharing and let Nick take over.
And I'm going to use this to also segue into the Stereonet mobile example, if that's all right, because that's the next thing that's happening.
That'd be great.
Great. Okay. 1 second. Okay. All right. So this is a data set that I collected in Strabo 1 in 2018, actually just before Strabo 1 kind of had its most stable version released. And here it is loaded just fine in Strabo 2. Everything's there. And so this is in Western Australia. It's my PhD area in the Pilbara Craton. And this is a large granitic dome that I spent most of my PhD working on. And then it's kind of surrounded by these very sheared supercrustal volcanics and stuff. So I did some sample collection and a little bit of mapping in there. And so this is just to show you kind of what a relatively large data set will look like in Strabo 2. And this is an iPad that's a few years old. I bought it in 2017. So a pretty big data set, and it's quite responsive and snappy. So all of this is a good case where Strabo2 functionality can really help you search through and find the exact observations that you're looking for. As you can see, there's a lot of different data points here. And, the one way you could start looking for things is just by tapping on different spots and opening up the notebook and saying, oh, is that what I was looking for? That's a pretty inefficient way to go about looking for spots. What I really like about Strabo2 is that if I know that in this little, you can maybe see that this is a large scale fold with the blue spots. If I know that I'm looking for a spot in this area, or I'm interested in a sample that I collected here, then I can open up the notebook view and I can say, well, I just want to see the images, and I've selected up here map extent, right? So it might take a few seconds if there are lots of images, but it loads up and I can look through and I can say, oh yes, I was actually, I was interested in this sample that I collected, and here it is in place, right? So it's a way for you to really quickly find what you're looking for. And you can do that for actual samples as well. So this, now this view is showing me only the samples that I collected in this area. And if I were to zoom out, then it would just be showing me basically a much longer list, all of the samples that I've collected. So, for example, I could say, well, I know it was like in the 100s somewhere over here, but what sample am I actually seeing here? Oh, it's maybe 102, right? Is the sample that I'm looking for, and there it is highlighted on the map. So that's just in terms of the kind of searching through your data. I think in earlier versions of Strabo, it could be easy for data to get kind of buried down in the spot structure. And we've tried in Strabo2 to solve that problem largely by this kind of searching through map extent, so you can search geographically for your data. The other thing that I really like, and this is functionality that's also in Strabo 1, but I'll just show you, is that the Strabo app doesn't have the ability to plot things in a Stereonet, because this is primarily a kind of data collection tool. And so we decided to partner with Stereonet Mobile that has a very advanced Stereonet plotting system that's made by Rick Almendinger. And the way that you can do that, so in the field, I use this all the time after a day of collecting data. If you tap on the map actions button, these 3 dots, you can lasso the spots for Stereonet. And what will come up is basically the freehand line drawing tool. And if I say, well, I want to see how those data that I collected today plot up, then I can say end draw, and it pops up with a little window that says data has been copied to your iPad clipboard. And then I can switch apps. I can go to Stereonet Mobile. And in Stereonet Mobile, the home screen looks something like this. And if you're not familiar with it, and to add data from the clipboard, you simply go to the top right-hand corner where it says data, and then in the bottom you say open here. And you can open from a text file, or you can tap for clipboard text. So we had just copied from Strabo to the iPad's clipboard, which is the kind of copy and paste temporary memory. And now if I say tap for clipboard, I'm just going to replace the data that I already had in there. So I'll hit replace. And now here are all those measurements that I had from Strabo. And there's both lines and planes that got copied over. And if I go to Stereonet now, you can see that these are the data that I had measured in Strabo. And now you're in Rick Allmendinger's advanced plotting system. So you can say plot configuration, and you can say, I want to view cam contours. I want a cylindrical best fit mean, right? You can do all the things that he's spent a lot of time building to create an advanced plotting software. So this I found really useful in the field because it allowed me to, as I was, maybe at camp at the end of the day, say, okay, well, what are the different areas that we've gone to, and do they have similar measurements or different measurements? I should note that you can also, if you're just going out and collecting measurements, you can actually fully use Stereonet Mobile to collect those measurements. And then in data, when you say save, sorry, I have to name this. When you say save, it asks you, do you want to save locally or do you want to upload to a Strabo Spot project? So when you click that, you can enter your credentials and it will show all your projects on strabospot.org, and you can upload these data into a data set on the Strabo Spot server. So you can have, if all you're doing is that kind of measurement data collection, it accesses the Strabo vocabulary, so you can categorize by, if I tap in the top right corner, I can say it's a fault and it's a dextral normal fault, right? This is imported directly from the Strabo vocabulary, so you can within Stereonet access that vocabulary. And because it's just a kind of lasso and copy and go over the other app and paste, I would kind of do that over a bunch of different areas in my map, and just compare them, right? Or plot over each other, and you could see, and you're in Stereonet, you have the ability to kind of color code the planes manually. So I would color code the different areas that I was trying to plot up to compare with each other. So that's a very useful tool, and it's pretty streamlined. Is there something you want to say about that, Doug?
Not at this point. That's really cool though.
Yeah, and this kind of brings up something that we hope to see from more community members as the years progress, is that we have a public API that anyone who has experience programming, it's pretty trivial to access, and you can have an application that is really specially tailored to your field needs. If you make that app, you can log into Strabo and access that data as long as you're using the Strabo data structure, right? So we hope that people will adopt the Strabo data structure and create apps that do have more advanced functionality than what we've created, or more specialized functionality. We have created something that kind of tries to capture all the different segments of the Strabo Spot community, at least the field portions of those communities. But you can make an app that really just does a deep dive into one specialized need, and it doesn't have to use all of the Strabo vocabulary, right? It can just use kind of the portion of the data structure that is relevant to your subdiscipline. So yeah, so anyway, that's kind of one of the things that we hope happens over the years.
Nick, there's a question from Kurt. Is there a way to export Stereonet plots you create, ideally like in a vector format?
I actually think yes. I haven't played around with that for quite some time. But yeah, I think it's this share button. sharing that, I think it allows you to export. It's either image or a PNG or a it's either a PNG or a PDF file that you can export.
Yeah, Stereonet supports all kinds of exports. You can also export your Stereonet data and use it on the desktop version of Stereonet that Rick Allmendinger puts out. The mobile version is iOS only. He's only developed that for iOS, but if you collect the data and then want to take it to either Mac or Windows, there are Stereonet versions of both, or Stereonet versions for both. All right, other questions on this? We're zooming kind of through everything today, which is fine.
Well, we have a question I'm not sure we answered. Is there a way in Strabo to represent scan lines for systematic data collection? Randall, can you clarify what you mean by that?
Yeah, this is Randy. For field work to study the systematics of fracture populations, we commonly do an outcrop-based traverse approach where we essentially collect data along an approximately one-dimensional line. Mm-hmm. And each time we hit a feature, we document its size, orientation, mineral fill if it's veins, slip direction if they're faults, what have you. In any case, of course, all these data that I'm talking about right now were already collected, and Strabo Spot seems to be primarily a tool for acquiring new data as opposed to visualizing data that you already have. But if I were about to go do a new traverse, would there be a workflow that I could use to collect data systematically along a line of observation?
So is that different here? I'll share my screen again and see if I see what you're talking about. So for example, you might say, well, I want to cross these various units perpendicularly. And so for example, you could ahead of time just draw a line saying I'm going to do that traverse and then add point spots to it. So is that kind of what you're talking about? Or are you talking about kind of grouping the data by traverse?
I'm mostly just thinking about right now, at least, about representing a traverse that I already have. So for example, I commonly will keep the GPS tracking running as I'm going. So I have, GPX files or something like that that literally show the path. Yeah. But I don't see a way to upload my GPX file to actually plot it on a map.
Well, if you can convert that to a shapefile, you can plot that on the map through strabospot.org. You can upload a shapefile into your project. So that would be one way if you do want that granular GPS tracking detail. Otherwise, like if you're collecting a bunch of spots, actually, this is a good, I'll cancel that. This is a good example right here. I was doing a approximately linear traverse here. If I wanted to group that or kind of show the path that I went, here I'll go to satellite data. I could choose to simply draw a polygon around them. It's not as exact as maybe what you're talking about, but if I do that, then I've essentially built in a hierarchy, right? Because I can tap on that that polygon and go to show nesting, and it'll show me all of the spots within that transect and all of the subspots within those spots. So so you can do that if you do want to kind of have that grouping preserved in the data structure.
With
Thanks,
what?
Nick.
Sorry, go ahead.
I was just going to say a related question is, I think you guys showed this maybe a couple days ago. Is there a way to import a KML into Strabo?
Right now, the only way to do that is to use some kind of GIS program to convert that KML to a shapefile. We basically only deal with uploading shapefiles.
Got it. Thanks.
Yep.
One of the, just kind of add on to what Nick was saying, one of the functions in Strabo 1, it was continuous nesting. So basically what it did is if you turn that on and you started a traverse, you would add spots, but it would continually create a home or a larger spot around all your data that would represent the traverse. So for the use case we had for that was you were traveling down a canyon collecting data. You couldn't get out of the canyon, but you wanted all those data grouped together. You would just start adding data. And at the end of the day, what you would have is you would have a large number of data points, and you would also have an enveloping polygon that contained all of that information. So that gives you a spatial or a relationship, a graph relationship between the data and another feature, which you could use to then pull it out. When you do the traverses, if the traverses have individual points in them, you could just aggregate the points to bring those into Strabo if you wanted.
Cool. Thanks a lot.
Would that be a workflow that might work for you, Randy?
That sounds cool. Thank you.
Okay.
Liz has a question. Are you planning to implement continuous nesting in Strabo 2?
Yes, it hasn't been put in yet, but that's coming too. There's a couple features that or a couple ways of working with data that we're getting started with that, to be honest, wasn't clear how often people use them in Strabo 1. So they got put on the back burner. Continuous nesting is one of those. We were talking, sorry, Nick, we were talking about something else the other day, and I'm trying to remember what it was that we had put on.
Yeah, I can't remember.
Yeah, I'll try to remember. Anyway, there are a couple of features that we'll be putting in that in changing programming environments, they're a little more challenging to implement. And so there's a couple things that are, in Strabo 1, you could, if you had a spot with a whole bunch of measurements under it, you could actually add a tag to different measurements at different times. We called that feature level tagging, but basically it means that you could sit in an outcrop and take a lot of information and tag your single observations differently. Again, that's something that's in the works, but it wasn't clear how widely that was used in Strabo 1 as well. So this kind of points out two different, and we discussed this in the Geosphere paper for Strabo, different ways that people work. Some people will sit down at a particular point and collect a huge amount of data, but as far as they're concerned, it's all in the same place. We have one workflow that allows that. Other people would never want to do that. They would say, okay, every single measurement I take is going to be spatially distinct from another measurement, and I'll do whatever I have to do to make that work. So there's part of the Strabo workflow development was to accommodate both those ways of collecting data. Are there any other questions? Okay. So I'm looking at our schedule. I don't think we need to do any more of the desktop work. That puts us about 10 minutes ahead of schedule. So why don't we do this? Why don't we go ahead and take the break now, and we'll come back at the top of the hour, and then we'll have the remote server demo and something on data management, and then we'll go from there. Is that okay with everybody? Not hearing any
Sounds
complaints?
good to me.
Yep,
10 minutes or 20 minutes?
20 minutes at the top of the hour. I have 40 past right now. Scott? All right, so we'll also stay on if people have other questions or they want something else shown or demoed. And thanks for Rip, thanks for showing data and all the questions so far this morning. All right. All right, so we're in break. Nick, did you use feature level tagging when you were working?
No, nope. But that's partly, it had been implemented by when I was using it, but I was using kind of a pre-release Strabo 1, and there were I had at that point I'd run into a few bugs, so I was trying to keep it kind of as simple as possible. But I could see it being. I was also doing more kind of campaign style, like trying to cover significant ground, and that's not really the use case for feature level tagging usually.
Yeah.
But I can imagine if there were, if your field area were kind of focused on 2 or 3 really complicated outcrops, then your spot level might be a picture or something.
Yep.
That then you have other spots in, or maybe you just want to keep it at that picture level, but you want to tag things as multiple, like one measurement is this generation of fold and one measurement is this generation of fold or something like that.
Yeah.
So I think it's useful for a subset of workflows.
Yeah. Yeah, I usually was just, I had a couple examples where I was basically doing F1, F2 on an outcrop, and I would tag differently with that. But that didn't happen very often. It was just nice having those together, because then basically everything plotted up and you could read the tag and basically see that the F2 foliation was axial planar, etc. Just kind of fun things like that. Well, I'm going to jump out for just a couple minutes. Jason will be on at the top of the hour to do the drone stuff. I've got the data stuff ready, and then we'll just take any questions and do wrap up at that point.
Yep, sounds good.
Okay, see you in a few minutes.
Yeah.
All right, everybody. Hopefully everybody's pretty much back. Good to see you all here again, virtually if not otherwise. So this afternoon, or after our break here, we've got a couple more data intensive and data focused presentations. The first one is going to be Jason Ash, and he's going to be talking about what do you do if you're running a campaign in the middle of nowhere, or as KU used to do, teach field camp from a camp that had no internet and still be able to work with all the Strabo functionality? And part of the imagined use case for this is a remote setting where you were, for example, flying drone imagery, processing it on the fly where you were, but you had no way of getting on the internet to put it on your iPad and use it for mapping. So what we're going to show you now kind of makes all of those sorts of things possible. So Jason, you want to take over?
Yep, sure. Let me share my screen here.
Should be ready.
All right, let me know if you can see that.
We can see launch meeting. There you go.
Okay. So, like Doug said, one of the problems with working out in the field with especially a mobile application is the lack of internet access. So, so issues using Strabo mobile in the field. The first is lack of internet access. You have a need to back up data, a need to collaborate with other students, other scientists in the field. And you have the need to generate and use other file types, like importing shape files or exporting spreadsheets from your data that you've collected, that sort of thing. And as Doug said, you also sometimes will need the ability to use other imagery, such as drone imagery or composite imagery you've created in the field. So let's step back a minute and talk about the Strabo server architecture. Early on, when we were deciding how to build the back end, there were some clear needs that we had that we wanted to take into account before we started. The needs were the need to be modular, the needs to be scalable, shareable, extensible, and the solution that we came up with is to put everything in a Docker container. So the StraboSpot backend runs in the cloud in a Docker container. This allows us, like I said, for everything to be modular, highly extensible, and ultimately shareable, which is kind of what we're leading to here. So what is Docker? So Docker is essentially, if you think of a virtual machine, it's just shy of a virtual machine, meaning it contains all of the code and libraries that you need to run an application, but it runs in sort of a cross-platform way, meaning if I have a Docker container, I can run it on a Windows machine, or I can run it on a Linux server, I can run it on a Raspberry Pi. A Docker image will run basically anywhere that you want it to run. And so StraboSpot Offline, the solution for the offline version of StraboSpot, was born out of that Docker container that we use for our real backend. So it's basically a copy of the actual Strabo backend. It's pared down quite a bit. There's quite a bit of code missing, but everything that you need to actually run a backend in the field exists. It'll run on any hardware. Usually in the field, we use a laptop. Since you're running off a battery, that's the easiest thing to run off of. It's Windows and Mac OS compatible, like I said, or Linux even, if you so desire. And so here's sort of the layout that you would have in the field if you wanted to run the Docker Strabo backend in the field. Essentially, you have a portable Wi-Fi router. I meant to include a link here and I forgot. I can send that out if anybody's interested. But basically, you have a small battery-operated router that can run in the field, but with no internet. Essentially, what it's doing is it's providing a Wi-Fi access point for all the devices to connect to, including the Strabo offline server you see down here in the lower right. So the Strabo offline server here would just be a laptop running that Docker image that's available at strabospot.org. And as you can see, there's no internet required. Everything is run locally on the laptop. So even without internet, you can use the Strabo mobile app to back up and back up your data, create imagery, download tiles, that sort of thing. So here's what the remote interface looks like. If you've seen strabospot.org, this is basically what it looks like. The only difference being that it has an offline notation here at the top. And as you can see, you can work with your data almost as just like your online, meaning you can export your data as all these different formats, and also import data from shapefiles as well if you want. And like I said, if you have the ability to capture, let's say, drone imagery and create a big raster, you can import that into the Strabo Spot offline system offline out in the field and pull tiles back into the app. So one thing Doug wanted me to mention is within the Strabo mobile app, the only thing that you need to do in the field to take advantage of the offline server is to change this endpoint. So whatever your IP address of your laptop is, you would put that in here, and that would point your mobile devices to the offline server and allow you to back up and pull data. And that's all I had for the slideshow. I have actually on my laptop here, I have the back end running. If I run localhost here, let's just using a web browser to hit my local machine here, you can see there's Strabo Spot offline. I'm logged in as the, it comes with one account when you download it, which is the admin account. But if I've logged in as the admin account, and you can see that these are all the typical features you'd have at stravospot.org, but these are all running here on my local machine. We have a few more options here where we can add users because we wouldn't have all of the users from stravospot.org on there clearly. So you'd have to add some users that you wanted to use in the field. But yeah, that's basically how it works. I think, Doug, you've used it in the field with Field Camp. I think it works pretty well so far. We've had good success.
Yeah, until last year, our field campsite had no internet access. So we used this container to run it in, and the add users, we would use all of that to add field camp students. So if we had some, we could set all this up ahead of time, or we could just set it up once we got to camp. If you were working in a group and you had your somebody come in and out, or you unexpectedly change one of the tasks, you could change users for that. It has the other functionality that is really important here, which is my maps. So again, if you're acquiring image in the field that you want to map on, how do you get a drone image onto a tablet without an internet connection? It's not easy. And this should make it very easy to do, this uploading to the server, and then it'll work just like it works in your office, except for you can be in the middle of nowhere for doing this. So that works quite well. We use this for probably 5 years. We used this implementation before we had internet at our field camp.
Liz is asking a important question, which is where's that field to specify the database endpoint in Strabo2, and we have mockups, and the programmers, that's like on the next few weeks. So that's a issue. The short answer is Strabo2 does not currently have a place to text field to enter that, but we're working on it.
Where will that go? Where did you mock up that going?
It's going to be in the settings and preferences, under the preferences subheading. There's going to be an actual, right now it says shortcuts and naming conventions. All of that is going to go probably under a greater preferences, of a kind of unified preferences area, and the database endpoint will be the top field in that. That should be
pretty quick to get in place, I think. So we'll
Yeah.
We'll try to have that, maybe move that up so we can get that endpoint link in there now pretty soon, next version that comes out.
Yep.
Other questions or anything else with the offline version?
Gavin is asking, is there any sort of documentation available for the remote server specifically related to installation / deployment?
Yeah, so I'll post a link in the chat where you can download this. What you do is you download a zip file, and within the root of that zip file, there's a README PDF that goes through step by step on how to install it and use it, and the devices you could buy from Amazon, the router I was talking about. Everything.
You want to show on the regular Strabo where that where you get to that?
Yeah, so it's just strabospot.org, Strabo spot offline.zip.
So in other words, it's not linked to directly in the public.
Well, yeah,
not linked.
Yeah, I think it might be. Let me look. I'll post the link in the chat. Just
like a year ago when I last checked, it was not directly linked.
Okay.
So maybe we should add that.
Okay.
I thought it was linked, so.
I thought it was too, maybe in the help section. I'll look, Nick, and I'll let you know.
Yeah. Pretty sure it's linked somewhere, but I don't remember where. Other question, any other questions? Excited to try it out. Yeah, I tested this, the latest version a couple months ago, and it all functioned fine. Just dropped it onto an old Apple laptop I had. And again, the Wi-Fi that you need for this is almost nothing. It's like a $10 box with a battery, and it's really, really simple to get. You will have to have some ability to do power, but again, simple solar setups are usually sufficient. And if you do have other power, it's fine. Batteries with inverters work fine. We, for a while, ran all of this remotely off of just the charger in a car, and that seemed to work fine too. All right. No other questions? All right. Well, I'm going to go in now and do a bit of presentation on just kind of the data structure and some of the things like that behind Strava Spot. This is a little bit of the nitty gritty, but for those who want to understand more about it, I hope this is all helpful. So anyway, okay, he's got the link in there. Let me go ahead and I'll share my screen. And again, the idea for Strabo Spot here with this Strabo tools set of examples is you want to be able to use devices, collect your data however you want, and then be able to interact with a database, and in this case, with Strabo Spot. So when we come into this, we're kind of coming in from a direction of thinking about field data in terms of a long tail. And this approach is pretty popular. It's been popular for 10 years in talking about data in general, but the long tail view is basically comes from marketing. And the idea is that you have some items like a Ford Focus that for a while was the biggest selling car in the world. 10 million sold in 2012 or something. I don't remember what it was. Anyway, it sits here at the peak. That's what most people access. That's what most people want and have available and can deal with. On the other hand, you might have like an Aston Martin 177, of which there are like 6 made a year, very, very specialized. And this relates to data as well. And you as a geoscientist relate to this every day. So when you're teaching, if you're teaching, like many of you do, you might have a map like this of the Ring of Fire sitting around the Pacific Ocean with earthquake centers. And this is a nice representation. All you want is the little dots there of different sizes. And that's kind of it. That's all you need. That's the expertise that you need to have this. But on the other hand, where does that data come from? And typically what happens is you have a bunch of records. These are an example of the Sumatran earthquake from 2012, very large earthquake. And some scientist somewhere sits down with these, actually this might be automated, but you sit down with these actually very detailed records. Most people that saw the map before, this means nothing to them. So the map before was the example of the forward focus. It's what everybody can look at and appreciate. This now is out on the long tail. And so this is the sort of data that the scientist works with. And then they, like the USGS for Tonga, will make a plot like this, and this will make more sense to a lot more people. And they'll be able to consume this, and this is kind of in the middle of the tail. And then finally, you get this whole idea of this tassographic subduction zone picture, where you take the earthquake, you plot a seismic cross-section, and then finally in a textbook, you have something that 1 million people can look at and say, okay, yeah, I understand that. So this is sort of how we're thinking about data being packaged. And as an expert, as a domain scientist, you're out on the long tail. When you're out in the field collecting data, taking pictures, analyzing color index, you're out on the long tail trying to collect this information. But then you have to package it up and make it sensible. And that's usually kind of the middle of this diagram when you publish a paper. And then you know, those people can appreciate the long tail, but then somebody might take that paper and make a cartoon out of it. So with Strabo spots, we're starting out with a geologic map. So this is a geologic map from a place in California. The rock units are all labeled on here. There are strikes and dips, symbology, etc. Contour lines. So if you're a good geologist, this is actually already a 3D representation, because you can just look at the map with the color fields, contour lines. You already know how structures dip based on how they interact with topography. So as a user, you're pretty highly skilled at dealing with this. But then again, most people aren't. So we want to be able to package this up in a way people can understand. So it's really complicated data. Points, lines, and polygons, a topographic map that quantitative scientists think of as one of the most complicated data-rich graphics there is. You have observations that you're making in the field, and then you have all kinds of different things that are very difficult to share and to integrate together. If all you have is a paper map and a field book, how do you share that? How do you make that available to everybody? And for just a field area like this, how do you make those observations repeatable? If you're a scientist, if you're a geologist, how do you make this so somebody else can come out and look at it and repeat the experiments that you've done or the data collection you've done? So that map, again, is an example of something that's pretty far out on the long tail. With the detail that's collected there. What isn't would be this geologic map of North America that GSA and the USGS put out. This is the version meant for general consumption, and then the level of expertise has to increase quite a bit to get to the map in the lower right. So that's what we are trying to do, is encapsulate that so that it can be distilled out and people can work with the data and anybody can get to it. So when you're doing that, you put up some kind of user interface for data collection. This is just an example from ArcMap, an old example from ArcMap, where you had data that was classified. So you see in the center part here that you have depositional contact known, non-conformable, etc. So you're able to classify this data, and then you're able to edit it. You can have controlled vocabulary, for example, and work all of that stuff together. And And that's an important thing. You control the vocabulary, you have a limited representation that people are using, and that's a way to start thinking about the data and start sharing it. So eventually you want to take those data and share them with people, and what we normally do with that is share them in some kind of database. And what is a database? Here are 3 different definitions, but your image here is you've got data and it's organized. So I think the last one is especially appropriate for rapid search and retrieval. So you can find the data you want and collect it and be able to reuse it. So that's what a database is. And so we need to get our geologic data into a database and make it as complete as possible. Kind of the simplest database that you can think about is a flat file, a table. So this is some isotope and age date information, all arranged in rows and columns. And you got the heading, you know what the data are, and you got that little note at the bottom of the table where the analyses were done. And this is what you think about. Well, this is fine if you're reading a paper, but if you're a computer trying to rip this apart and search it and put things around, you typically don't do it quite this way. You start breaking it up a lot more. And part of that breakup is thinking about what the metadata are. So you have this data value and sample name, and that was in the previous table. But what you want to be able to do then is say, okay, 708.286, what does that mean? So then you need some information about standards, normalizations, and methods. So this is the metadata that you have that's really critical to understanding how the data works. And much of this metadata, though, is really, really redundant. And you could expand the size of a file by many, many factors, just repeating metadata after metadata. And that can be inefficient and unwieldy to some time, at some level. So the solution that came about for this, again, this is an older solution, but probably one you're more familiar with, is the idea of thinking about this as a relational database. And a relational database is one where you'll have a data entry that has an item and a value. Then you have a key sitting out here. That key takes you to another table that has redundant information repeated. So for this value, you have one set of information. For the silica, iron, and magnesium, you have another method, XRF, where you don't know too much about. But the point here is that you can have lots and lots of values here, and you never really repeat all the metadata. You just repeat a key method number here that gets you between 2 tables. It tells you how to relate one table to another. And so this grows and grows and grows. You have one table that's your values that has a method number. That method number then has some values that then goes to a lab. That lab doesn't need to be repeated all the time. It has a lab number that maybe you know how to access that lab. So the keys allow the referencing from table to table, and each table contains unique entries. You don't want any repetition. If you've heard about this, this is called a normalized database. And for relational database, is the key for developing them has been normalization, trying to get them flattened out to the extent that you can. And then what you do is, after the fact, you join the data together through these keys and tables, and you just kind of cascade through the tables and pull data together. That relational database is a pretty rigid structure, and it uses relational algebra. Relational database doesn't mean relations so much between tables. I mean, that's a practical way of viewing it. But it's really based on relational algebra, which is part of discrete math and set theory and things like that. So for example, this first line is a definition that you could use for doing the Cartesian product of two data sets, for example. The point is this is rigid, everything's rigid, it's very, it has to be arranged just right. And once you have it arranged, you really can't do much to the structure of it. It's really efficient for storage, but it becomes inefficient for finding data at some point, especially when you look at a schema for a complicated database like NavDat or EarthCam that looks like this, that has, I don't even remember how many tables there are in here, but there are a lot, but it's a highly normalized data system. Which is great for storage, and say 30 years ago was really what you needed 30 or 35 years ago, 40 years ago, when a big hard drive was a couple of megabytes. And those relational schemas were very efficient in storage, but they were just a complete headache to understand, and nobody ever wanted to see those. So what we've done, and I introduced this on the first lecture, first day of this webinar, was thinking about a graph approach. And this is basically saying, okay, we're not going to worry about storage. We're not going to worry about normalization. All we're going to be concerned with are relations between observations. So like strikes and dips in a layer, that the same layer, and that all of these come from the same structure. So this is a graph approach. It's taken away from the relational approach, and that's where we're at with Strabo Spot. And if you go into almost any data system that you're going to use now, there'll be some kind of graph structure to it. And if you're in some kind of social network, it's all graph structure. And so it's really because of computational speed and computational advances is really a much cleaner and a faster way to sort through these data. All the same, though, we still have to have some rules. And for us, those rules are the lexicon, which we talked about the first day, is basically we want a controlled vocabulary. And that controlled vocabulary is just fundamental for people to be able to search and understand the results that they're getting out. It's not because we want to make this more efficient or anything like that, although that's a byproduct, but it just means that once you learn the vocabulary, you know how to get through the structure. You're not dealing with somebody's sort of random classification of folds, for example. So we still have a few rules, but not nearly as many. And again, as I said on the first day, we use something for transfer called Geojson, which basically looks like this. This is an example of Geojson. You say it's a feature point, that's its location, and that's something about it. The point here is that this can be very short, like you see here, or it could fill pages and pages of information if you wanted. This is, again, is based on a standard specification. And like I said on the first day also, this is something that computer programmers and data scientists know how to read. So this was an example of Mike Taylor's data from South America. Again, Mike has no idea what Geojson is about. GitHub has very little idea what the tectonics of South America are about. But because we're using this protocol, one side doesn't really have to know what the other side does and doesn't have to know all the details. And it's sort of at that level of being able to convey data sort of independent of context that makes it very powerful. You carry the context with it, but you don't have to be a geologist to read a Geojson file. Likewise, you don't have to be a computer scientist to export to Geojson from some program or some programming language. The other thing that was mentioned, and Nick mentioned it today, that's very important part of what we do is something called web services. And so you end up with these data formats, Geojson, and you say, okay, anybody can read that. Anybody can grab that. How do I grab it? And you grab it using something called web services. And what that is it's just a very simple way to send requests from a server to a client or a client to a server. It's all done out in the open without too much worry about security, and you can return whatever you want. When you go online and you put in a request and you see the URL is about 5,000 characters long with whole bunches of funny looking characters in it, that's basically using a web service. It's sending some information, requesting, and then getting information back. A couple of the things in this is one really important thing is that it allows server-side processing. So what this means is, and this is like the translator you might be using, Google Translator, you enter in some text. Your computer doesn't contain any sort of German to English translation software. It just knows to send that out to the web service at Google that reads it in from this simple message, and then it returns back to you the translation or the meaning. So it lets people keep very specialized software and use it like that through something that we normally call an application programming interface. You don't have to remember this, but I just bring it in case you've heard people talk about APIs before. That's essentially what they're doing. They're taking a string, a message you send it that says, hey, talk to me in this way, and here's your answer. So that's what we do with web services. This whole idea of Geojson, very portable, very open web services, is again something we talked about early on with fair data, findable, accessible, interoperable, and reusable. And fundamentally, you can package data this way, and that's how Strabo Spot is doing it. It's trying to be fair. You have an interface where you download, you serve the data in either Geojson or GIS formats. It has all the metadata with it, including images, photographs, whatever you want. And in that way, your data are findable. It can interoperate. The JSON can be, or GIS can be used in various programming environments. It's accessible through the interface, and then it's reusable. You can pull the data in and use it however you want. So on interoperability part, we have showed this before, the fact that you can go into Strabo Spot and select ways to download it, shapefiles for GIS, KMZs, XLS, Stereonet, Fieldbook I showed examples of in strat sections. So here's a Fieldbook view. You could grab some data and share just in something like this. You've got strikes and dips and what unit it's in, or you bring in a KML file into Google Earth and you're able to visualize data around a folded structure. And as Nick showed you this morning, just pulling some information out and putting it in Stereonet. All of these are done and package it up in reusable formats. So the way we think about this is that, we're out on the long tail where things are much more specific. I guess in a way, you can look at Strabo Spot and some of these other systems as sort of cleaning up the detritus of the dinosaur out on that long tail, and trying to keep that together, but package it in a way other people can reuse. That's the data presentation format of this, part of this. Just one reminder to you about something we'd like you to do if you feel like it, and again, we're not telling you how to do this, but just do it, is go ahead and rate Strabo2 and Strabo tools and review them on the App Store. Any review is good. It helps our numbers with people seeing the app, but it also helps us in giving us feedback. All right, so that is the that's what I wanted to tell you about the data structure, and just kind of as a request for what we've got going on. Nick or Alex, Jason, anybody else want to add something to APIs and relational algebra and all that? Nope.
Nope.
Nope. Jason, you got anything you want to throw in?
No, nothing for me.
Okay. Well, looking at the schedule, we're getting pretty far along. We're going to have Nick do a wrap up and take any questions now, and then Noah's here. Will be putting a link out or asking you about a survey. So go take it over, Nick.
Sweet. So yeah, so that is basically the workshop. We've taken you through some basics of how to use Strabo2, and talked a little bit about the Strabo spot in what do we call it, Doug? Sorry. The Strabo spot ecosystem. Yep.
Yeah, the ecosystem.
Yep. And so hopefully what we wanted you to leave this meeting with was, if you were kind of new to the Strabo spot system, a better idea of what it looks like right now, and also kind of our vision for it going forward. So I have a very brief wrap-up presentation that isn't really a presentation at all. One thing that we want to emphasize is that, we do a lot of internal testing, but we're only a handful of people. So if you experience issues with the app, or have suggestions about the app, please do contact us, because this is and always has been a community-driven project. So we want to hear if something isn't working in the app, or something that is consistently frustrating you about the way that we designed it. Alex or Doug, what is the kind of contact email that we use for that, if people want to give some feedback?
Stravospot at Jason, Stravospot at gmail.org?
Gmail.com.
Gmail.com, right.
So email this, and we monitor this email, and it's kind of where we get issues from people who are using it out in the field and are experiencing problems. And also, we want to remind you that what we've released, version 1 at this point, version 1.1.0, is the kind of core functionality of the field app, but Stravospot 2 development is ongoing. So coming this summer, we're going to have data pages that relate to igneous and metamorphic petrology, more kind of detailed fabric descriptions, and the ability to tag individual features within a spot. And then we're starting this development now, and it's going to come sometime later, hopefully within kind of the 8-month time frame, that we're going to build out the sedimentology vocabulary and the strat column building mode in Stravospot 2. So watch out for that as those features roll up. If you are going out into the field later in the summer, make sure that you come back to the App Store and keep up to date with those versions, because we'll also be fixing bugs as we encounter them.
Nick,
we are also...
Sorry, there's a question. Can you mention how often,
sure,
whether you plan to update the app this summer? So I guess maybe how often?
Sure. My impression is that that depends on bugs that we catch, but it will probably be within the bi-weekly time frame. Correct me if I'm wrong, Doug.
I think that's weekly or bi-weekly. Yeah, I mean, we had two versions released because of the testing you guys have done this week. We've already updated it a couple times this week, but we probably will be more or less at the week to 2 week period. If there's a major problem, it usually gets done then. So you could see a day turnaround time on that. It takes about half a day or a day to, once you have a bug fixed, to get Apple to put it up on the App Store.
Yep. Yeah. So we will, especially when we first release an app and get suddenly a lot more people using it, there are going to be bugs here and there that we've caught. So, for example, we've now gotten rid of those all of the information buttons that were kind of crashing the app. Now they're either not there or they lead to something. So that's already up on the App Store. And that was a bug that you all found. The other thing I want to bring your attention to is that we are going to be holding weekly office hours this summer that are meant to be a kind of troubleshooting sessions for people using it, Strabo in the field, or if you're getting prepared to go into the field. And I don't believe we have those firmly scheduled yet, but we'll send out a follow-up email with the details on that. Alex, is that right? We haven't set a firm time?
I think they're going to be Thursdays from 11 to 1 Central Time.
Okay.
But yeah, we're going to send a follow-up email to this workshop, and I'll include some details in that email as well. And we're going to have probably some sort of information on the website as well.
CDT.
Really? There you go. So now we have 15 minutes left. I guess we have one more thing after this. Is that right?
We have the survey after this.
Right. So now
Noah
is an
will be running.
opportunity before the survey, if you do have further questions, and it looks like there are a few questions here. Randy says, I think you mentioned earlier in the week, but what is the prognosis for Android? So the prognosis for Android, as I understand it, is that it is not our top priority because most of our user base of Strabo 1 was iOS, but it is completely achievable because we wrote this in a cross-platform environment. So there will eventually be an Android version. I think, Doug, do you want to go further on that?
I can say a couple things on that. So at this point, it looks like things function okay in Android. As Nick said, this is cross-platform development, so it should all work just fine in Android. Where the glitches come in, potential glitches, is where we're using routines that address directly the iPad, the physical components in the iPad. And so that's what we'll have to do for the Android version, is probably put in a little bit of extra work to see how using a compass might work. And it may be that if there's a lot of variation in the Android world, it may be that we'll just say, okay, use your Brunton with Strabo in the field for Android. The foot photography, again, that's something like getting the orientation of the iPad is pretty easy using iOS, but we don't really know how that's going to work for Android quite yet at this point. So it's working, but there's a couple issues that's on the hardware side that we need to make sure we get. Okay, Nick.
Are there any other questions?
as far as updates are concerned, if an update appears at the App Store, when you get on your mobile device and you have an internet connection, you should see your App Store icon should have a number by it saying how many updates you have available. And yes, we can hang around for a few minutes at the end. Absolutely. Okay, any other? Well, I guess that's it. The survey link is there. Please follow up with that. And as I ask at my blatantly and shamelessly at the last slide, go give Strabo2 and Strabo tools a rating if you feel like it. Anyway, I think that ends it. Thanks, everybody. This is also available if you want to go back or have any questions that you think were answered in here. You can run back on YouTube and look at that. And I also appreciate your participating in getting this ready for YouTube, because now we have a lot of content that's been run through people, real people that we can put up on YouTube to help other users. So thank you all very much. And thanks to all the co-conveners and the developers and everybody else who helped us out. And you're all welcome. I'm seeing some thanks in the chat. It was our pleasure. So we can stay on it for a few minutes if anybody has questions, wants to ask stuff. Liz.
Of course, I have questions. So it's partly just nervousness. So I and one of my colleagues and a couple of our students, we're going to be using Strabo2 in the field this summer. And of course, we want to actually get some research done. So I'm just wondering if should we also have Strabo1 downloaded in case something goes wrong? I mean, we're going to be not so far from home. So it's not a huge deal if something crashes in the field, but I'm just wondering like what you might, because so my colleague Sean Mulcahy, he's used Strabo1 a fair bit. We haven't really mapped on it, but just to collect data. But I'm just wondering kind of what sort of backup plan we should have if all goes haywire, or if you are good enough, you think like we shouldn't worry about it.
I think with Strabo1 that you wouldn't have to worry about anything much at all. And honestly, with Strabo2, I would say a month from now, you wouldn't have to worry about anything at all, really either. The glitch with the information icons that you saw, that's the first thing that we found through beta testing, actually, that caused the application to just stop. The other beta test on Strabo2 didn't really do anything like that. And the other thing a couple of people on this webinar found is even if it does blow up, all your data are being saved continuously as you're working. So,
is that true if you're offline?
yep. So as you map, as you use the app, you're saving the data to the local device.
Okay, cool. That's good to know.
So if you go ahead.
There is one instance where that you can check before you go to the field, and that is you should always check that you can back up to the device. Basically, we have had a couple instances where, and it was mostly going from the beta version to the actual release, where backing up and uploading got broken temporarily only if you overwrote, if you didn't delete the previous app. So what I always do before I go into the field is still in internet connection without having input any of my precious data yet. I put some spots and then, so I create the project that I'm going to create in the field. I put some spots, and I back up to the device, and I upload to the server. And if those two things work, then you're pretty much safe, because you know, if the app does crash, then you open it back up again and you have daily backups.
Okay, great.
So yeah, I agree completely.
Something
with
that you do makes the app crash. Say it again.
You had a little bit of lag there, but I agree completely. The only thing I ever really lost sleep about with Strabo was the backups. And I didn't worry about Android because you could stick an SD card into it and back up daily. And now you can do that with iOS. So even if you're in the middle of nowhere, you shouldn't have a problem. If your iPad dies out of power, nothing gets lost. SSD devices are, you know, they're pretty darn good.
So that you get an adapter to plug into the little port.
Yep.
Yep.
And if you have your phone with you, and how often do you go anywhere without a phone, you could just airdrop your data to your phone as a backup. So that's the nice thing, is with the backup, it goes to the file system. You can airdrop it a bunch of different places at any point. If you took field camp from me, the first thing you do when you get back out of the field is make 2 or 3 backups. And I just hammer on students to do that. So if you're a paranoid back or upper, you'll be fine.
The other thing is it does not hurt to download Strabo 1 and just have it there. You have someone in the field who is really familiar using it. So if something about the new app just isn't fitting your workflow and you're there with someone who really knows Strabo 1, the data are completely interoperable. So, you know, just collecting on Strabo 1 is not gonna kind of make the data set outdated or anything. You can then later download it on Strabo 2 once whatever issue you run into is fixed.
Okay,
So,
and you don't know of any interference problems between them on the same device?
So
nope, I have both on my iPad, and I did some field work, and they're completely separate apps. So they don't do any kind of overprinting of each other or talking to each other directly on your iPad.
Use the same project name when, like, if you set it up in one, or you have to have a different project?
Nick?
You can ahead of time download the same project from the server down onto both of them. In the field, they won't talk to each other in the field. The two apps don't access the same data on the iPad. They're completely separate. Okay. But you can then upload both of them. What I would suggest, if you midway through decide to switch over and you don't have an internet connection to be able to upload from one and download to the other, just start a new data set in the other app. Just start a brand new data set, and then you'll never have any interference issue.
Yep.
Perfect.
That's all perfect. And this is a caveat, I think a couple people and a couple of our beta users found. If you're going from a beta version of Strabo Spot to a production version, you really need to get rid of the beta version before you install the production version, because that's the only time we've ever found conflicts.
Yeah.
Production versions shouldn't have any issues, but the beta versions can, and we find out about that a lot because we're always running beta versions to test.
And the production version is what comes from the App Store?
Yes.
Yep. Yep.
Absolutely.
So once you're on the App Store, you can just hit update. You don't need to do the deleting the app and all that stuff. But I would still every time you update, check that you can first do a backup before you update, and then check once you update, can I still make a backup to the device? Can I still upload to server?
Okay.
And the answer will always be yes, but you should just, that's so critical when you have that, when you're collecting that data, right?
And if you update to if you can get to the App Store, you can update your project to the server. And once you do that update, it makes a copy. First thing it does is it makes a version before it even copies any of your data over. So updating the server actually makes a backup as well.
So I also do want to say something that I do, again, just out of paranoia, which is that I always turn off automatic updates on my iPad. So this
Okay.
isn't something in Strava, this is something on your system preferences.
Right, I just checked it and I have it on at the moment, so.
Yeah, so I always turn it off, and the reason is because when I'm in the middle of something, I want control when I update, because if I get to internet connectivity, the first thing I want to do is back up my project before I update. I don't want the app to update without me knowing, and then, for whatever reason, for it to break something. So I always turn that off, and then I can just go to the App Store and click update when I'm ready, because otherwise it'll just start updating as soon as you're connected to the internet, if we've pushed out an update.
Years ago, probably 3 years ago, we would occasionally have an issue with iOS updates, that something would break. Jason, can you remember us having to fix anything like that in the last 2 or 3 years?
No, I can't.
Yeah, when we first started, in 2016, that could happen, but I think since 2017 or 2018, that has not happened.
Nope. It's just to make myself feel better, right?
So Gavin
but I think it's good practice. Yeah.
Is there a specific workflow for uploading projects created in the offline remote server, the official one? The easiest thing is just make sure that whatever's on your device, your iPad, is the most current version. Change the endpoint and just upload to the server. That's really, you don't have to, just delete resetting the endpoint and pushing the online server. That's it. Always back up to device. Again, when I'm in the field, I might back up to device a couple times while I'm out in the field during the day. It takes like 3 seconds. And really the only way you should lose that is if you lose the iPad. But if you lost your field book and your map, you'd be in the same position. So just don't lose your iPad or don't lose your map.
And my other question is, I got awarded to participate in this testing feedback program. Is there going to be some instructions about how you want us to provide feedback, or?
That's Randy's running that, right, Nick?
Yeah, I think we're in the coming week, we're gonna reach out to you and give you some more details.
Okay, awesome, thanks.
When are you going into the field?
Well, I'm gonna go do a little test in a couple weeks, but our main field season, it's only a couple hours from home, so our main field work is gonna be in late July, so.
Okay.